All right, now number 6, we have a couple parts. A 4-digit passcode can be set to lock certain electronic devices using numbers 0 to 9. Suppose numbers cannot be repeated. So, part A. What's the probability that the passcode contains the digits 1, 2, 3, and 4? So real quick, before we actually solve this, is this a permutation or a combination problem? Well, think about your phone, right? It's a 4-digit passcode. I know on my iPhone I have a 4-digit code. I know some phones do 6-digit. Whatever it is, order matters, right? Whatever my 4 numbers are, I have to type them in that specific order every time to unlock my phone. I can't just, if this is not my number, but if it's 5, 6, 2, 8, right? I can't type in 8265 and get into my phone, right? This is a permutation of those same 4 numbers, a different permutation. But we treat them as 2 different objects, right? Because it's a passcode. Order matters. So this is a permutation problem. I don't know what that is, but yeah, permutation. I'm just going to erase that. It's probably going to erase everything. I knew it. I'll fix it. There we go. For permutation. Okay, so now let's do this problem. What's the probability that the passcode contains those digits? Contains 1, 2, 3, and 4. So we want to be careful with the wording here. They're just saying that the passcode contains the digits 1, 2, 3, and 4. So they're not saying that it needs to be in the order of 1, 2, 3, and 4. It just doesn't matter the order, but we need to have those 4 exact digits in the problem. I shouldn't say the order doesn't matter. Order does matter. And what I mean is, just like I did up here, 5628 is different from 8265. And in this problem, we just want to make sure that these 4 numbers are in the passcode somewhere. Okay. So let's figure out this probability. So on top, we want to figure out the number of ways to pick those 4 digits. But again, remember, 1, 2, 3, and 4 is different from 2, 1, 4, 3. So when we count the number of ways to pick those 4 digits, we actually need to count each permutation, right? Like, for example, another one could be 2, 3, 4, 1. That's different from these other 2. However, it has the same digits, right? 1, 2, 3, and 4, just different orderings. So on top, the number of ways to pick those 4 digits, well, we can actually continue using the permutation notation. So there's 4 numbers we have to pick from, right? 1, 2, 3, and 4. And we're trying to pick all 4 of them. So we can write this as 4 pick 4, which you will actually see 4 pick 4 when you plug that into your formula for permutations. What we end up with is 4 factorial over 0 factorial, which is indeed just 4 factorial. So, on the bottom, So the top was, the number of ways we can pick out those 4 exact digits, but accounting for the different orders of those digits. Now on the bottom, we want to figure out the number of ways to pick any 4 digits. 4 digits. Out of all the digits we have to pick from. We can pick from 0 to 9, and if you count that out, there's actually 10 numbers from 0 to 9 when we're including 0. So there's 10 numbers, but we want to pick out 4 of them. And order matters, which is why we're using the P for permutation. All right, so you can work those out. Again, you can plop into your formula. On top, we get 24. That's 4 factorial. Or the same thing as, 4 pick 4. And then on the bottom, 10 pick 4, you get 5,040. And then I'm going to go ahead and simplify this to a decimal. You get 0.00476, and that's rounded to 5 decimal places. Okay, so that was part A, where we just wanted to figure out the probability that your code had those exact 4 digits in there somewhere in some order. Let's take a look at B. So B is, what's the probability that the passcode is 5643 in that order? So they're telling us what's the probability, or they're asking us, what is the probability that the code is exactly that, 5643? Well, the top number, once again, is the number of ways to pick the sequence 5, 6, 4, 3. And well, there's only one way to do that. There's only one way to have that code in that exact order, 5, 6, 4, 3. We don't have to do this permutation like we did for 6A, because they gave us the digits, but they didn't tell us a specific order. They were just wanted to know the probability that your code contained all 4 of those. But now we want to know the probability that your code is specifically these numbers in that exact order, and there is only one way that can happen. And that's, by picking 5, 6, 4, and 3. And then again, on the bottom, it's the number of ways to pick any 4 digits, which is something we figured out in the last problem. 10 pick 4. So simplifying that, we get 1 over 5,040. And if you simplify that, you get 0.00020. So again, another really small probability. One last one, 6C, and I'll put that right underneath here. So we're still working with these passcodes, but now someone's trying to break into your phone. They can see which 4 numbers you use for your passcode due to the fingerprints on your phone. What is the probability that this person breaks into your phone on one try? Okay, so I'm going to put the probability, breaks in. So, on top, you want the number of ways that person can break into your phone. Well, if you think about it, kind of similar to this last problem, you only have one code for your phone. So there's only one way for anyone to get into your phone. They have to type in that exact code. So once again, we have a 1 on top. Now on the bottom, this is not the same as parts A and B, because now they know what 4 numbers are in your passcode. They just don't know the order of those numbers. So this is the number of ways a person can try those 4 numbers, right? They know exactly what those 4 numbers are. They just don't know the order of those numbers. So we have to figure out how many different orderings can we have for those 4 numbers, whatever they happen to be. So we're still working with permutations. There's 4 numbers we have to pick from, and we're trying to order all of them. So we can write this as 4 pick 4. 4 permutation 4. Because once again, we know all 4 numbers that we have to pick from. We just don't know the ordering. So we're picking 4 numbers and we're ordering all of those same numbers. And this is another value we've already determined from part A. We did 4 pick 4 over here, which is equal to 24. So 1 over 24, or you can write that as 0.04167. Okay, so those are a couple problems on probability with permutations and combinations. It definitely takes some practice, especially trying to figure out, okay, what am I trying to figure out for the top number? What am I trying to figure out for the bottom number? So when I picked out these problems for this video and for the notes, I used the homework as a guide. So if you're struggling with a homework problem, please refer back to the notes. See if you can find a problem that looks pretty similar to the problem you're doing. It may not be exactly the same. The situation might be a little bit different, but I guess the process is the same. So yeah, use these notes, use these videos as a reference while doing your homework. And please let me know if you guys have any questions. Again, this is tough content, especially if you're not used to working with combinations, permutations, and probability. This might be all new to you, and it takes some time. This is one of the sections that I actually really prefer to do in class, because I could sit here and do examples all day, but I won't ever be able to cover all different possibilities that you'll run into with these problems. And really the best way to learn it is just kind of grind through it and work it out in groups with some, fellow students trying to figure it out. But we don't have that option, unfortunately, right now. Some of you might actually be happy about that, which is fine. But, the other side of that is you guys are all at home having to kind of struggle with this stuff on your own. So again, please, if you're really confused on something, let me know. I can make another video on a specific Hawks problem, but you have to tell me what the problem is, and I need to know exactly what that problem is, so you could take a picture of the problem and send it to me, or just copy it into an email. But you have to let me know exactly what the problem is. If you're just oh, it's this combination problem, that's not going to help me. If you want me to make a video on it, I need specifics. So, okay, I'm done with my spiel on that. There will be more videos to cover the rest of the notes.